transect. Steps to follow when using transect method to estimate populations. Select the area of study. Make a sketch of the whole area selected above. Fix one peg firmly on the ground and tie one end of string or tape or any other material that can be used to the peg. Fix the other peg firmly on the ground at a different part of the area but to cover the total length of the string to be used. Mark the string starting from one end to the other at 1 meter intervals. Count and record the number of the organism of interest that falls along the line in intervals on a table. Find the average number of organisms and use it to estimate the population of the organism of interest in the whole area of study. The video clips below show students estimating the population using line and belt transect methods. Click on the play button to view the video clips.
Line transect is a method that is used to estimate the population of organisms that are not mobile. In doing so, you use a rope. You place a rope at the area of study, then you place a quadrant and let the rope run across at the center of the quadrant. And then you count the number of organisms according inside the area of study. Then you take the quadrant and place it at regular intervals. In placing at regular intervals so that you can get the average of the organisms.
Put it down.
Then after an interval of 2 meters, we place the quadrant at the next point. 1, 2, 3, 4, 5, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 34, 35, 36, 37, 38, 39, 40, 41, 42, 90, 91, 92, 98, 99, 100, 101. So
So we place the food rat at the next point.
One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
One meter, 2 meters, 3 meters, 4 meters, 5 meters, 6 meters, 7 meters, 8 meters, 9 meters, 10 meters, 11
One, two, three, 4, 5, 6, 7, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 301, 302, 303, 304, 305, 306, 307, 308, 309, 310, 311, 312, 313, 314.
Capture-recapture method. This method involves the following steps. 1. Capture of organisms using an appropriate method, for example, fishnet for fish and a pitfall trap for crawling insects. 2. Mark the captured organisms using an ink or varnish which should not have any effect on the organism. Count them and release them. 3. After a fixed interval of time, capture organisms for the second time and count them. Among this group, some will be marked while others will be unmarked. Count them separately. Repeat the same procedure severally. The population is then estimated by number of organisms initially captured multiplied by the number of organisms recaptured divided by the number of marked recaptured organisms. Play the video clip below to see students estimating the populations of mosquitoes using capture-recapture method.
We count the number of organisms that have been captured and mark. After marking the number of organisms inside we release them into the ecosystem and let them intermingle freely. After 24 hours, we come back again and recapture. Come again and count the total number of organisms that you have captured and the total number of organisms that had been captured earlier. Those are the recaptured organisms. After counting them, we release them into the ecosystem.
This method is based on the following assumptions. Organisms mix freely in the population. Enough time is allowed for mixing between capture and recapture. Organisms' movement is restricted to the geographical area under study. That immigration, emigration, birth and death rates are negligible. That the marking does not interfere with the free movement of animals or make them less camouflaged to their predators or poison them to death. Adaptations of plants to life in various habitats. In this section, we shall learn about the distinguishing characteristics that plants possess to enable them thrive in desert, terrestrial, water, and salty marshes. Different habitats are inhabited by different species of plants with varying abundance. These plants thrive in different habitats because they have characteristics that suit them to these habitats. These characteristics are called adaptations. The adaptations enable the plants to grow in areas with different levels or quantities of the abiotic and biotic factors. There are four main groups of plants, namely xerophytes, mesophytes, halophytes, and hydrophytes. Xerophytes. These are plants that are adapted to life in a dry habitat to endure prolonged conditions of drought, as in arid and semi-arid areas. These habitats are characterized by low humidity, winds, very high day temperatures and low night temperatures, and unpredictable and poorly distributed rainfall. Adaptations of xerophytes. Leaves are modified to spines or thorns to reduce the surface area over which transpiration can occur. For example, acacia. Leaves have thick waxy cuticle to minimize the rate of cuticular transpiration. Some plants roll or fold their leaves to reduce the rate of transpiration by not exposing stomata. Play the animation to see rolling of leaves by plants on hot days to reduce the surface area exposed to sunlight. They shed their leaves during the dry season to reduce the surface area exposed to transpiration. The animation shows a tree shedding off its leaves during dry weather conditions. Have reversed stomata rhythm to reduce the rate of water loss by transpiration. Have reduced number of stomata to reduce the rate of transpiration. Swollen stems and leaves for storage of water, for example, cactus and baobab. Leaves have resin coatings to increase reflection of solar radiation, hence lower transpiration rate. Others possess very deep roots to absorb water from deep in the soil, for example, acacia and others. Some have superficial roots that grow horizontally, for example, acacia. Roots are close to the soil surface to absorb water after a short or light rain.